My name is Burkett. I'm an aerobatic display pilot, and it's my pleasure to display this beautiful aeroplane in air shows and other events up and down the country. The aeroplane is an Extra 300S. It's a top aerobatic performing machine that was designed and manufactured by Walter Extra, who's a German aerobatic pilot and designer. It's incredibly strong and stiff aeroplane, and it's rated to very, very high G limits, in fact to plus 10G and minus 10G. And through my display sequence, I'm very often touching forces of 9 times my body weight, so 9G, and negative G forces of minus 5 or minus 6G. The aeroplane is capable of extraordinary manoeuvres because it's a very powerful machine, and it generates enormously powerful gyroscopic effects from its propeller. And this helps us fly a whole new class of aerobatic figures, such as the gyroscopic manoeuvres, which allow you to really present the aeroplane flying sideways, backwards, and tumbling end over end. The aeroplane is powered by a 6-cylinder, 300 horsepower Lycoming engine, and its capacity is about 9 litres. So it's an extraordinarily large engine, and its lineage goes all the way back to just after the Second World War. The airframe of the aeroplane is extremely strong and stiff. The wings are made out of carbon fibre as the main wing spar, and it's covered by glass fibre panels. The fuselage structure is a steel tubular framed structure, which is also very strong. And aside from the certified G limits of plus or minus 10G, the structure itself has been proved to have an ultimate failure load of 24G. So when you're flying this aeroplane, you can have complete faith that the aeroplane is not going to be falling apart. The limit is much more likely to be you as the pilot rather than the aeroplane. The aeroplane has a maximum speed of 220 knots, which is about 250 miles an hour, and it has a stall speed, which is a normal slowest flying speed if you're flying straight and level, of about 60 miles an hour. But at points during the display, I'm at 0 miles an hour and even flying backwards. For air displays, the aeroplane is fitted with a smoke system. This consists of a smoke oil tank of about 35 litres capacity, and smoke oil is injected into the exhaust of the engine where it vaporizes and turns into a white smoke. This gives me 7 to 10 minutes of smoke for a display, which is more than enough. The aeroplane is a wonderfully responsive machine to fly. For normal operation, it has finger-light control forces, and it's only really when you start to push high G levels during a display that the forces get heavier, and sometimes you have to use both hands on the stick. In fact, let me show you the control surfaces on the aeroplane, which are enormous. These are the ailerons. They're almost full span, as you can see, and they give a really high rate of roll to the aeroplane. 400 degrees per second, so more than one rotation in a second. And you can achieve even higher roll rates with this aeroplane in a flick roll, where you also introduce rudder to stall one wing but not the other. They're aerodynamically balanced by a spade underneath, so the control forces, even on full aileron deflection, are really remarkably light. The design of the aeroplane is such that these huge control surfaces are possible because the wing is so stiff. This aeroplane has a carbon fibre wing spar, and it's so stiff that you can fit enormous control surfaces as we have here. On the tip of the wing, the device fitted here is an aerobatic wing sight, and when I'm sitting in the cockpit, I have a line of sight through this apex of the triangle, which allows me to tell if my wings are exactly level, and when I pull into a vertical manoeuvre, I can position this rear edge of the wing sight onto the horizon and check both sides and make sure that I'm precisely aligned and not introducing any yaw in the vertical. On this side, I also have a special turning vane which is quite useful at the top of vertical manoeuvres, where you're drawing a line in the sky but getting slower and slower, and you reach an apex at the top just before a stall turn. And this device, which has a little counterweight at this end, as the speed reduces, this vane flops, and at the point that it flops you're just at a very low airspeed, and you're able to then time your stall turn and kick rudder, so reverse back down into a dive. I also have a little piece of wool fitted to the wing sight, and that's useful for tail slides, where the aeroplane is actually going to be reaching the top but then sliding backwards through the air. And of course, when the aeroplane starts flying backwards, this string, this wool, will reverse, and I'll be able to get a visual indication of when the airspeed has reached zero and is starting to go backwards.